looking at linear relationships. A linear relationship is the relationship between two variables that appears as a straight line when graphed. Linear relationships fall under coordinate geometry, which provides a link between geometry and algebra. The Cartesian plane or number plane consists of two axes, which divide the number plane into four quadrants. We have the x-axis, the y-axis. Okay, the horizontal x-axis and vertical y-axis intersect at the origin and at right angles, giving the first quadrant, the second quadrant, the third quadrant, and the fourth quadrant. Okay, a linear relationship is a set of ordered pairs, x and y, that when graphed give a straight line. Remembering when you're graphing ordered pairs, the x, the first value, goes across, the second value, the y, goes up or down. Linear relationships have rules that may be of the form y equals mx plus b, for example, y equals 2x plus 3. This is known as the gradient intercept form. And ax plus by plus c equals 0, for example, 2x minus 3y plus 4 equals 0, which is the general form. And we'll have a look at those in a while. Okay, we're going to plot points to graph straight lines. Using x between -2 and 2, construct a table of values and plot a graph for y equals x plus 2. So the rules y equals x plus 2, draw up your table of values. We have the x in the top, y in the bottom. Because it's between -2 and 2, we're going to put -2, -1, 0, 1 and 2 and find the relative y values. That when you substitute those x values into that rule, you get the y value. So first one, we have x equals -2. So -2 plus 2, that gives you 0, so y equals 0. When x equals -1, we have -1 plus 2. That gives you 1, so y equals 1. X equals 0, 0 plus 2, so y equals 2. When x equals 1, we have 1 plus 2, that's 3, so y equals 3. And when x equals 2, 2 plus 2 equals 4, so y equals 4. Okay, our number plane, we draw that up. Remember to label the axes, the x and the y, that's important. Okay, so plotting those points. So remember the x goes across, the y goes up and down. So we go across to -2, we don't go up or down because it's 0. The next one we have go across to -1 and we go up to 1. Place a point. Next one is 0, 2, so the x is 0, y is 2. Next one, x is 1, y is 3. And x is 2, y is 4. And you'll notice when we've plotted those points, we'll have a straight line. Now to graph that line, all we do is draw a line through those points and making sure you put an arrow on each end. Okay, we're going to find the rule now. Find the rule in the form y equals mx plus b for the following table of values. So I've been given a table of values this time. For the last one, I had a rule and had to complete the table of values. So we're doing the opposite. So the x, I've got -2, 1, -1, 0, 1 and 2 with the relative y values, -4, -1, 2, 5 and 8. So first thing to find the rule. We need to see what the y values are going up by. So if we've got -4 to -1, that's 3. -1 to 2, 3. Similarly, 2 to 5 and 5 to 8, 3. So they all go up by 3. That's good. That's the start of finding our rule. So we start writing the rule. We have y, because y is the one at the bottom. So y equals 3 times x. So 3 times the top one. So we check that rule and see if that works. So y equals 3 times x. So when x is -2, we substitute that in. So 3 times -2, it's not -4. That's checking if we need to make an adjustment to the rule. So we've substitute -2 in, 2y equals 3x to get -6. So we need y equals -4. What adjustment do we need to make to -6 to get -4? So when I get -2 times 3, I get -6, but my answer has to be -4. So what I need to do is add 2. So the rule is y equals 3x plus 2. Let's just check it. 3 times minus 2 is minus 6, plus 2 is minus 4. Good. Okay, also, we don't just check the first one, we need to check the others as well. So when x is minus 1, 3 times minus 1 is minus 3, plus 2, that's minus 1. Good, the rule works there. Okay, going to x equals 0. 3 times 0 is 0, plus 2 is 2. Good, that one works again. When x is 1, 3 times 1 is 3, plus 2 is 5. Good. When x equals 2, 3 times 2 is 6, plus 2 is 8. Good. So the rule for that table of values is y equals 3x plus 2. Now just to rehash what we did then, firstly we found the common difference in the y values. It was 3. That becomes your coefficient of the top pronumeral, in this case x. So we have the bottom pronumeral equals the constant that it's going up by times the top pronumeral. So y equals 3x, then you look for an adjustment by substituting one of the amounts in, the x values. Whatever you get, this one we got minus 6, we realised we had to add 2 to get minus 4. That's the way to get your rule. Okay. Reading off the x and y intercept. Example, using y equals x plus 2, write down the x-intercept and the y-intercept. The x-intercept is when y equals 0. Okay, looking at your table of values, you want to find the x value that y is 0. So looking at your table of values, we have x equals minus 2 and y equals 0. So x equals minus 2 is going to be the intercept. Looking on the graph, when y is 0, so looking at the vertical axis, y is 0, so we're at the origin here, and we're going across to minus 2. So the x-intercept is minus 2. Okay, the y-intercept is when x equals 0. So looking back up at your table of values, we've got x equals 0, y equals 2. So the y-intercept is going to be 2. Now looking on the graph, you go to the horizontal axis to 0, so at the origin, and we're going up to 2. So the y-intercept is 2. Okay, so remember we can get the x and y-intercepts off of a table of values, or we can get them off our graph. We'll learn another way to do that later, algebraically. Okay, rearranging linear equations. Our example, 4x plus 2y equals 10. We're going to change that into the general form and the gradient intercept form. So firstly, let's look at the general form. It is ax plus by plus c equals 0, where a, b and c are constants. And a has to be greater than 0. That means it has to be a positive number. Okay, rewriting our equation, 4x plus 2y equals 10. So we've got a starting point. Now, looking back at the general form, we've got everything on one side and 0 on the other. So we need to do that with our equation. So first thing, we need to get rid of the 10. So because it's plus 10, we're going to subtract 10. And we end up with 4x plus 2y minus 10 equals 0. And that's in general form. The 4 relates to the a, the 2 the b, and the minus 10 is the c. So there we have 4x plus 2y minus 10 equals 0. Okay, let's have a look at the gradient intercept form. Y equals mx plus b. So we'll have a look at this in the future, where m will be our gradient and b will be our y-intercept, but that'll come around later. So y equals mx plus b, so m and b are going to be numbers, constants. Okay, so writing our equation again, we have 4x plus 2y equals 10. So we need to get y by itself, so make y the subject. So similar to the algebra we've done before. So let's have a look. We need to get rid of the 4x because we want y by itself. So let's subtract 4x from both sides. Okay, 4x cancels from this side. So we have plus 2y equals minus 4x plus 10. Now the reason I've written the minus 4x first is just to make sure it looks like our original equation, mx plus the constant. Okay, so now we need to get rid of that 2 because I want y equals. So let's divide every term by 2. So you need to be careful, it does need to be every term. So 2y divided by 2, you get y equals minus 4. X divided by 2 is minus 2x. Plus 10 divided by 2 is 5. So we have y equals minus 2x plus 5. So really, rearranging these linear equations is similar to what we were doing before, but it's just in a context of linear relationships. Okay, so just using your algebra skills, you're manipulating and rearranging. So back to this, y equals minus 2x plus 5, gradient intercept form, and 4x plus 2y minus 10 equals 0 is the general form.